So a relation is just any correspondence between two sets, some kind of relationship. Typically, we're thinking about sets of ordered pairs. When you're looking at that, X is your input or your domain value, and Y is your output or your range value. A function is a specific type of relation where each input, so each X, corresponds with exactly one output. So basically each X goes to one Y. Or another way to think about it, if it's a function, X never repeats. So an example of a function, X plus 2. Okay, if I put in 3, what do I get out? 5. So X is my input, 5 was my output. Can I put in 3 and get 2 different answers out? No, that's what makes it a function. If I say like x squared, or about, if I said something like x equals y squared. If I put in a 4 for my x, what would y equal? 2 or negative 2. So is that one a function? No, because one x value would go to 2 different y values. All right, so first thing, we're just going to practice all the different ways that we might see relations represented. We can see tables, mappings, sets of ordered pairs, graphs. So we're going to practice looking at these, deciding if it's a function, and giving the domain and range. So this first one, is it a function? So all you're checking, do any of these repeat? Nope, so this is a function. I just abbreviate FN for function. My domain, those are my input values. I'm going to put them in a set. That's 1, 2, 3, and 4. My range, that's my output or my Y. What output values do we get? Even though 3 is listed twice, we're only going to put it in the range once. And it really doesn't matter what order you put those in your solution set. I tend to do increasing order, but if you jumble them up, it's not a big deal. It's the same. B, is this one a function? No. Why? The 3 repeats. So this one's just a relation, but we can still do domain and range. What's the domain? 1, 2, 3, 4. And the range would be what? I have a negative one over here, but do I ever even use that output value? No. So my range is just the 1, 4, and 7, the only outputs that we actually got. So how about if I gave you a set of ordered pairs? Is this one a function? Yes. What's the domain? Domain is just the x of each ordered pair. Range is your y, so that would be 4, 5, 6, 7. All right, one more. Is this one a function? No. Why? We have 2 points where negative 3 is the x value. What's my domain? And the range is my y, which would be put those in any order. Okay, so we might also see functions, and more often, represented with an equation. So I want to decide if these are a function. What are my options? Look at a graph. How would you know from the graph? Vertical line test. Do you guys remember that? Since you said it, I'm going to jump ahead a couple slides. The graph of a function always satisfies the vertical line test. So, grab a graph in the calculator and we'll check. If your calculator is showing up, there might be, you're graphing some things in stats. If your calculator doesn't show up with the graph, let me know and I'll fix it. It should just be a line, y-intercept -5, slope is 2, so it looks something like this. Does that pass the vertical line test?
Yes.
Yes, so this is a function. All right, B, we have a problem. Can you enter y squared in? No. In order to put it in the calculator, it has to be y equals. So if I took this and tried to get y by itself, I could subtract over my x squared. Then what would you have to do?
You take the
Square root. When you add a square root, what do you have to do?
plus minus.
Okay, so what you have is y equals plus and minus square root of 1 minus x squared. If you want to enter that in the calculator, you have to do two separate things. So when you go to your y equals, for y1, you can just do the square root of 1 minus x squared. For y2, do negative square root of 1 minus x squared. Everybody, it kind of looks like
I'm seeing an error.
Oh,
I'm
okay.
seeing an error.
It should do and negative.
Mine says 92.
Okay, anybody else?
That's what I got.
Anyone else?
Oh.
That's just not.
Why do you talk like
No.
Oh.
Ava, if I were you, I wouldn't handle that. I wouldn't do that.
Like a 5-year-old, actually.
I wouldn't make that slide if that was me. If Taylor said it to me, I would show them.
David said, what happened?
Someone told me I did.
Taylor said that?
No, I asked her
I said
why.
something to 5-year-olds.
She asked. That was nice.
You're welcome. Okay, if you actually get the right window, this is a circle. It's not the oval or the potato that it looks like. But either way, does this pass the vertical line test?
No.
No. Can you tell me from this equation what makes it not a function?
Does not pass the vertical line.
The fact that it doesn't, is there a way you could have predicted that just looking at the original?
Like X, Y.
when you solve for x, you had that plus and minus. If you have an x to an even power, x squared, x to the fourth, x to the sixth, you'll always get that plus and minus, and it's not going to be a function. Okay, I want to practice looking at some graphs and deciding domain and range from the graph. I know it's kind of hard to tell on your paper, it's just these points. So the domain is just the x value of each of those 4 points. So what would it be? -2, -1, 1, and 4. Range would be the y values of each of those. So that would be B. You did these last year with Mrs. Keller, and you had to write the inequalities, and you had to remember that domain was with x and range was with y, and write things like 0 less than or equal to x, less than or equal to 5, and so forth. We're just using interval notation on all of them. So domain is talking about your x. It goes from left to right. You're traveling along the x-axis. So if I'm coming in from the left, what's the first x value we hit? -1. Do we actually touch it? No. I think we do right here. So it gets a bracket, -1. Then I keep hitting it until, what's the last point? 5. And we do touch the 5, so -1 to 5 is my domain. Starts at -1, ends at 5. Range is the y. Small to large, so bottom to top. So the lowest y value we hit is -4. The highest y value is 2. Is that one okay? So let's see. This is a line. It keeps going in both directions. So if I'm going from left to right, this is going forever to the left, that's going forever to the right. So what do we end up hitting? All real numbers, except how do we write that this year? They get parentheses, you can't equal infinity. All right, what about my range? Same thing, this end's going down forever, that one's going up forever. So it is also negative infinity to positive infinity. Domain. So this is a parabola. So as it keeps going, it's going to keep getting wider and wider. So from left to right, what do we hit? All real numbers, so negative infinity to positive infinity. The range. Bottom to top. So the lowest value we hit, 0. We do touch it, so it gets a bracket. Comma. The last thing we hit, infinity, because it doesn't stop rising. Which of these are functions, by the way?
All of them.
All of them except. Good. All right. So on the next, we already said the vertical line test. Take a second, just on your own. Here's your practice. Decide which of these are functions. So is the first one? Yes. Is this one?
No.
This one? This one? Yes. So the first and last one are functions. Everybody got that? So we have just identified domain if I give you like the mapping or the graph. From the equation itself, we can also give the domain. There's a couple things we need to remember. One of them we've already seen. in a fraction, what can't happen? There's one thing you can't have in a fraction.
Zero.
The denominator cannot equal 0. The second thing is in an even radical. So that's like a square root, fourth root, so on. The radicand, that means the thing under the radical, has to be greater than or equal to 0. You can't do the square root of a negative. What do you get when you have that? Imaginary. In terms of graphing, we can't graph imaginary numbers, so we'll just be looking for real numbers here. So those are the two domain rules we need to watch out for. All right. So the next slide, I have a lot of equations. I just want to practice deciding if these are a function and giving the domain and range. And I know, I apologize, there's not a ton of room for you to write. Maybe you can use the margins or something if you need more. I didn't say how you had to get there. So if you wanted to just look at your graphing calculator, that's fine. The first one, y equals 2x minus 5, that's the same one that we already graphed and decided it was a function. But what we didn't do was the domain and range on it. So that's why I put it on here again. So this was the line that we already graphed. We know this is a function. What's the domain? What is your range? The second one, y equals x squared plus 3. Why don't you graph it? Let's look at this graph. All right, so you get a parabola that's been moved up just a little bit. So is that a function? Yes. What would your domain be? It's going to keep going in both directions, left to right, so negative infinity to positive infinity. The range, where does this graph start? At 3. You can tell if you put in a 0, 0 squared plus 3 is 3, so my range is 3, and then it keeps going up forever, so 3 to infinity. All right. C. Can the graphing calculator help me with this? No. Okay. So what do we do? Okay. So this means that either y equals x or y equals negative x, right? We've solved those. Since we're going to have to do domain and range, you could also, some people really dislike trying to solve this type of thing with the equation because it's still, when you go to graph it, it gives you more than you need. So if you wanted to graph these, it has to be y equals. So we have x and negative x. And so our calculator gives us just a big X on the screen. There is a problem with that. We know that the variable X here is equal to an absolute value. So absolute value is what kind of number? Positive. So if X is equal to that, that means X has to be a positive number. So really what it does is it takes off that part of the graph. So what does this actually look like? It's a sideways V. You could also make a T-chart if you didn't like having to think about that one a little more, and just plug in some points until we get it. But the actual graph looks like this. So is it a function? No. What would my domain be as we go from left to right? Starts at 0, goes to infinity. The range, that's the y, so from the bottom to the top. So this goes down forever, this goes up forever. So we hit everything. All right, this one. Thoughts? What does an inequality do? Do you remember graphing those? If you just graph the equation, y equals negative x, what do you get? Just a line, decreasing, negative slope. The inequality part adds shading to it. So y is greater than that. That means you shade above the line. Pretty much any inequality is going to involve shading. So is there any way this passes a vertical line test? No, because anywhere I draw a vertical line, it has to go through all of that shading. So if you see an inequality, you really don't even have to work it out. It's just not a function, not going to happen. Domain and range is going to be what here? That line keeps going forever, the shading hits everything eventually. So domain and range are both everything. All right, so we've seen a couple things so far that give us a big sign that it won't be a function. If x is squared, it's not going to be a function. If we have an inequality, it's not going to be a function. So there are some things to watch out for. E, why don't you graph that one? So you have 3 over, and then put in parentheses your x plus 2. We saw graphs kind of like this when we were doing our rational inequalities. So the graph looks something like this. Is that a function? It is. It looks like these are turning into vertical lines. They're really not. They're just flattening out. So this one's a function. Domain, you can tell from the graph. You can also tell from this equation. We know if it's a fraction, what can't happen? The bottom can't be 0, so x can't be negative 2. If you look at this graph, negative 2 is where this graph breaks into pieces. So my domain is everything except the negative 2. So how we write that, it's everything smaller, so it starts at negative infinity. It goes to negative 2. We don't equal that, so it gets a parenthesis. Union starts again after negative 2 and goes to infinity. So when it's just one number that x can't be, our interval breaks there, and they get parentheses. The range, can you tell from the graph what y value we never equal? Yeah, this one hits all the negatives, that one hits all the positives, but what we never hit is 0. So the range is going to be a lot like this. It's everything smaller than 0, so negative infinity to 0, union, and then everything bigger than that, 0 to infinity. I know these domains and ranges are not easy. We will be practicing them a lot more. Okay, this is just kind of the first day we're working on it, but this will come up through the entire chapter. So we'll get plenty of practice with this as time goes on. Why don't you guys try f? Decide if it's a function and see if you can give me the domain and range. So you get your graph. Is it a function?
Yes.
Yes, definitely a function. Domain and range might be a little harder here. So when we look at this, it's really kind of hard to tell exactly where this graph starts and stops. Domain, if you can't tell from the graph, which I really can't, I gave you a rule to help. I said if it's an even radical like a square root, whatever's under the radical has to be greater than or equal to 0. So that means 4x plus 1 has to be greater than or equal to 0. So 4x has to be greater than or equal to -1. So x has to be greater than or equal to -1/4. So that's where this thing starts, -1/4. So my domain is from -1/4 to infinity. You can also zoom in and things on your graph, and we'll practice all of that more. Range, again, it's kind of hard to tell. If you plug in a -1/4, what do you get out? So 4 times -1/4 would be -1 plus 1 square root of 0, 0. This graph starts at, the y value starts at 0 and goes up forever. Again, you might have to zoom in a little bit if you were trying to tell that exactly from the graph, but we will be practicing this a lot more. Okay, how are we doing so far? Are you bored? Can I keep going? Do we need to stop? Anybody has an opinion? Keep going? Is that okay? Okay, so function notation. In function notation, you don't see x and y. You replace that y with an f of x. So we will see function notation the majority of the time. When I see f of -2 equals 13, what would that be as an ordered pair? What's the x value? 2. What's the y? -13. Okay, so what you plug in is the x, what you get out is the y. So let's practice evaluating some functions. So here are some equations. If I ask for f of -3, so f tells me we go to function f, and this is what I am replacing my x with. So I'm going to plug in -3 for my x. So we have the opposite, -3 squared, minus 6 times -3 plus 4. Alright, so -3 squared is 9. Opposite would be -9 plus 18 plus 4. And I get out 13. B. So this is function g. So we go to g, and we are going to replace the x with an r plus 2. So that's 3 times x, so that's r plus 2 plus 4. So distribute, we get 3r plus 6 plus 1, or 3r plus 7. You may not get just a single number answer. You can have variables still. So the next example, I want you guys to try on your own. I've given you 4 different ways you might see a function represented. I want you to see if you can figure out what f of -1 would be in each of those. So keep in mind, -1 is your x. So on A, you plug in -1, so you get 2 times -1 squared minus 9. -1 squared is 1. So 2 minus 9 is -7. You guys get that one? The others are actually easy if you know what you're looking for. So this means x is -1. Tell me what y is. So if I look at this set of ordered pairs, when x is -1, what's the y? 6. C, x, that's your domain. So when my x is -1, what's my y? 5. D, on this graph, when x is -1, find the point on the graph. So here's the point where x is -1. What's the y value there? About 1/2 or 0.5. Sometimes we may take equations and put them in function notation. So you just have to remember that the f of x replaces the y. So if I gave you this one, if I said put this in function notation, you just change your y to f of x. So then what's f of -5? What does that mean? So -5 squared is 25. 2 times -5 is -10 minus 3. 25 minus 10 is 15 minus 3. B is different. Why? It's in a different form. Okay, if we're going to replace the y with the f of x, we need it to be y equals something. So I need to take this equation and solve for y first. Okay, you can add the y over, so it's positive. Then what would you do? And then what? Divide by. You could have done it differently. You could have subtracted the 2x and divided by -3. So you would have had 6 minus 2x over -3. That's equivalent. So my function notation, f of x equals 2x minus 6 over 3. And the benefit of function notation is then it's easy to ask you to plug things in. So I'm asking for f of -5. 2 times -5 minus 6 over 3. -10 minus 6 is -16 over 3. Do we need C? Just more of the same. Put it on there in case we need another. So, one last thing I want to talk about, okay? The last piece we need to go over with function is what it means for increasing, decreasing, and constant. The key to all these, you have to go left to right, okay? So, just like reading a book. Increasing is a graph that rises from left to right. So you have to be careful. This is increasing, but I have found if I do this, everybody says decreasing because the line is going down. But we have to read it left to right. So if I start at the left and travel to the right, it's rising. So that's increasing. Decreasing is falling from left to right. And constant is no change. When we look at a graph, and I'm going to ask you, where is this graph increasing, decreasing, or constant? You are going to give me an interval, just like we did with domain and range. You need to use your x values on that. So we'll do an interval. You have to use x. So you might highlight that or star it. that's the piece that gets people because they want to say the y value is going up, and so they want to use the y, but we have to use x. So I'd like to do the next 2 slides and then I'm done. We'll save probably that last one for Tuesday. So I just want to know where this graph is increasing, decreasing, and constant. So easiest option is just start on the left. So this graph starts at -8. What is it doing first? This is decreasing until where? Looks like about right here. Doesn't come out evenly. So we're decreasing from -8 to negative what? 5.5? What happens after negative 5.5? Increasing. So from negative 5.5 until it's going up. Does it stop going up here? No. So it keeps increasing until we want the x value, which is 2. Okay, then starting at 2, what happens? It is constant. From 2 until 6. And then what happens? Decreasing. Let's pretend that's just the top right there. I didn't really need the graph to go on. So it's decreasing until we get to 9. We already have a decreasing. If you have another one, you just put the U, the union. So that's from 6 to 9. Technically, with increasing, decreasing, constant, it does not matter if you use parentheses or brackets in uniform notation. So just be aware those might be interchanged, and that's okay. All right. Last one. What's this section of the graph doing? Decreasing. It's going up, but as I move from left to right, it's actually falling. Now this is going forever, so where is it coming from? Negative infinity. Until I get to -3. That has to have a parenthesis because it's an open circle. Okay, then my graph starts again at 1, and it is increasing from 1 to 4. And then starting at 4, it is constant forever. So 4 to 8. All right. You guys were a good sport and let me teach the whole class period. I know that's a long time to sit. So I appreciate that. The homework is on this slide, but you don't really have homework unless you are just bored and want something to do over the weekend. Tuesday, we have one problem that we're just going to talk about in class. It'll take me maybe 2 minutes. So we'll do that, and then the rest of the class period will be time for you to work on the assignment in class. Okay, so that's my gift to you for letting me teach the whole class period. You get a whole class period to work on homework. Bring your textbook Tuesday.